Okay, welcome to lecture 10.3. Let me just clarify one little thing about where we left off. So, when we go back to the crisis game, so remember the probability that one chooses F4, we're defining that as P4. And then we just wrote that that equals E to the lambda U1 W2 divided by e to the lambda U1 W2 plus e to the lambda U1 of C1. Okay, so that, no, sorry. So that is, okay, P4. All right, now, next thing we're going to do, given this exercise, the next one's going to be pretty easy. We're going just to determine P3, okay? And P3 is defined as the probability that state 2 chooses this branch given that we get to that node, okay? Let me tell you, I can tell you, I can tell you in words real quickly. We're just going to do the McFadden trick. So it's all 2's decision. So we're going to look at 2's scene utility for W1, compare it to 2's scene utility for C2, and we're just going to have a term something like this, where instead of U sub 1, we're going to have U sub 2. Instead of W2, we're going to have W1. And before we had C1, we're going to have C2. Okay, so that's where we're going. Let me just write that out. Okay. Q3 equals probability state 2 fights given that state 1 fights in first round. Okay. And so this is just going to equal e to the lambda U of 2. Remember, state 2 is making the decision. U of 2 of the utility she gets if they fight, and that's W1. If they fight, they get in a war where 1 started it. Okay, divided by e to the lambda U2 W1 plus e to the lambda U2 C2. And this is equation 6. Okay. All right, now, the next thing, let me go to the, all right, so that was a pretty easy one. Okay, now we want to do Q2. All right, now Q2 equals probability Q2, probability 2 fights. I write 1 minus Q. You know what? I think I'm not sure I have my notes right. I have I have Q2 equals the probability 2 does not fight. I don't think that's right. I think what we want is Q2 equals this one. Probability 2 fights, given that 1 does not fight. Okay. And now, this is going to be, this probability, okay, is going to be, we're going to look at 2's utility, okay? So 2 has to make a decision. We're going to add an error term onto the actions, okay? And they're going to be standard Weibull. So the probability that she chooses status, okay, yeah, okay. This is Q2. All right. You know what I'm going to do? This is what I did in my notes. Here's why I was confused in my notes. It's going to be slightly simpler if I examine the probability that she doesn't fight. And that is 1 minus Q2. So Q2 is the probability she goes down to that branch. 1 minus Q2 is the probability she goes down that branch. Okay. So 1 minus Q2, all right, so when we do the McFadden trick, it's going to be e to the lambda of 2's utility from the status quo, okay, divided by 2's utility from going down this branch, okay. Now, if 2 goes down this branch, 2 doesn't know what she's going to get. It might be C1 or W2. And so the expected payoff, the expected scene payoff is P4 times her utility from W2 plus 1 minus P4 times the utility of C1. That's the expected utility, okay? So here's what that equals. Let me write that on one more board. Let's see. I think I can do it here. Okay. So 1 minus Q. What did I write that right? Sorry, I want that. That's Q2. All right. So we're going to have 1 minus Q2. All right. All right. One minus Q2 equals probability 2 chooses, what did I say? A little f2, not given 2 reaches that node. Okay, so here's what I'm saying, that F2, 1 minus Q2, is probability that 2 chooses that branch given we get to that node. All right. That equals, okay, it equals E, we're going to do the McFadden trick, E to the scene utility going here, and so that is U sub 2 of status quo equals times lambda. We're going to put in, okay, lambda times U sub 2 of status quo, all right, divided by E to the lambda times U sub 2 of status quo plus E to the lambda of your scene utility from doing the other choice. Okay. And the scene utility of doing the other choice is going to be this weighted average of utility of C1, utility of W2, weighted by this P4. Okay. So that is going to equal lambda, let's see if I can write this small enough, lambda times P4 of u sub 2. So 2's making the decision. So utility for state 2 of P4 of W2. All right, so P4, that's the probability that state 1 chooses war. So it's P4 times the probability of war. And sorry, I ran out of room. 1 minus P4 times U2's utility of the other choice, which is the probability that state 1 does not choose war. So it's the probability that state 1 chooses big F4 bar, and then that gives the outcome of C1. So that's it. 1 minus Q2 equals this term. And this is equation 5. That's equation 6. Okay. So we're almost there. So now, and by the way, here's what we're doing. Eventually, we're going to talk about how to do a likelihood equation to estimate parameters. And so when we do this, remember your recipe, the first thing you do is you got to create a dependent variable. And the dependent variable is going to be the outcome. It's going to be whether we have status quo, C1, W2, C2, or W1. The probability of each of those outcomes depends on the probabilities of which state moves which way. So the probability we get to W1 is the probability that 1 goes down this branch and then 2 goes down this branch. Okay, so we've already got that branch, P3. All that's left is we got to know the probability 1 goes down this branch, and we're going to call that P1. So this right here is P1. That's 1 minus P1 here. So once we compute P1, we can start talking about the probability of observing each outcome. So the probability of observing W1 is just P1 times P3. The probability of observing C2 is just P1 times 1 minus P3. Probability status quo is going to be 1 minus P1 times 1 minus Q2, and so on. Okay, so that's where we're going. The last thing is just we got to calculate this P1. Okay, all right. Do that. You know what? I'm not going to write it. I think you guys get the idea. I'm just going to say it in words, okay? How we would do this, okay? So to calculate P1, okay, the choice is going to be player 1's, okay? So we're going to do the McFadden trick. We're going to add an error term of the utility of choosing F1, and then another error term, the utility of choosing F1 bar. Okay. Now so it's all player 1's utility. Okay. What is P1? Well, it's going to involve a whole bunch of terms of U sub 1, because 1 is making the choice, so it's going to be a whole bunch of terms involving the scene utility of player 1. Okay, and so what is that going to be? Well, the scene utility of choosing this branch is going to equal, let's see, I will write it. I'll write it with orange. So the scene utility for player 1 of choosing this branch is going to be a weighted average of those two outcomes, of the utility of those two outcomes. Okay, where the weights are given by P3, and that's the probability that 2 will go down that branch. So the seen utility is going to be P3 times utility for person 1 of W1 plus 1 minus P3 of the seen utility for person 1 of C2. Okay. So when we do the McFadden trick, the probability that 1 is going to go down this branch is going to be E to the lambda times all of this stuff in the numerator. The denominator is going to have that term again, E times E to the lambda times all this, plus another term, E to the lambda times the expected utility, the expected seen utility from going down this branch. Okay, and that is going to be, the weighted average of this and this, okay, where it's going to be 1 minus Q2 times utility of 1 of getting status quo plus Q2 times, okay, I'm going to put a big brace, Q2, you know what, I actually need lambda times this, lambda times Q2 times, all right, the weighted average of C1, where the weights are P4 and 1 minus P4. Let's see, I'm going to start with this term. P4 times U1 of W2 plus 1 minus P4 of U1 of C1. Okay, so that second term is going to be E to this stuff, okay? And all of that is going to give us the probability that 1 chooses this big F1. That's P1, okay? All right, so now we've gotten all the probabilities, okay? Let me now, I'm going to end there, and in the next video, I'm going to talk about what our likelihood function would look like, okay? And I'll do that. Let's see, this is 10.3, so I'll do that in 10.4. See you there.